All right, so welcome. This is building information modeling. You should be able to see this on your, basically your schedule should either say ARC 4050, ARC 6050, or ARC 6307D90. So if you're signed up in one of those, you're registered for this class. There's supposed to be 19 students right now, and it looks like I could probably fit in a couple more, so I know there's some that are on a wait list, so I might try to get a couple more students in here as well. You might have noticed at the very beginning of class, obviously I had a little bit of problems trying to get that to work. That won't happen again, but essentially when I teach this class, I always record what we're doing on screen and basically recording what I'm doing as the tutorial goes on, because this is going to be a tutorial-based class. You're going to be following along as we kind of go through Revit. And essentially what I do at the end of class is I post it to the website as basically a YouTube link to the video. So you can always go back and review what we did in class. I try not to pause it too much, so it's kind of the whole duration of the class, so you should be able to pick up anything that I'm saying during class and also see exactly what I'm doing on screen. So you have a lot of opportunity to go back just in case you missed something in class, because we do move a little bit fast when we work through a lot of the tutorials. And occasionally you might get lost and you might have to go back and do a couple reviews of what we're doing. Just to kind of briefly talk about this class, and then I also want to talk about BIM and Revit, which this class is basically revolves around building information modeling, and we're all Revit all the time. So we're going to be using Revit throughout the whole entire semester. And essentially you have access to Revit, obviously through all the school computers. It's Revit 2014 is what we're going to be utilizing, even though Revit 2015 just came out, basically I think at the end of May. The school is not going to upgrade to that until basically I think after this semester. So we'll be learning on 2014, but just so you know, I don't know how many people are familiar with Revit or not, but essentially since Revit 2013, each version that has come out has essentially been the same. They've just added more tools to it or made things a little more efficient. So Revit 2015 is going to follow the same kind of track that basically 2014 did as well. They're just going to add a couple more tools and make things work a lot more efficiently. How many here, before we get too much into what we're doing in the class, how many here have used Revit? So I got maybe 3, 4 people. Have you used it in office setting or just in school? School? Office? Okay. How many years do you think you guys have had experience with it?
I had the classes for a year.
For a whole year?
For a year.
About a year? Okay.
For a year, and then ArchiCAD for about a year.
Okay, so did you guys learn on 2013 or 14 or 11? Okay. 13?
12, I think.
12? Okay. What about you?
13.
13? Okay. So that's good. And then everybody else, I assume, has had some kind of 3D software experience, probably SketchUp. I'm assuming a lot of people get into that early. Maybe Rhino. Everyone's had some Rhino experience. Anyone taken computational methods? Everybody? Okay, that's good. So just to talk a little bit about this class, first of all, like I mentioned, I do have a class website, which is at that address at the very top that I'll zoom in one more time for you. www.jrodesign.com/Revit will take you directly to this site. Now this is hosted on my own kind of web server, and it's basically different from what I could do with the school servers, because I can basically get a lot more freedom on what I basically put up here, as well as I allow you to upload your assignments to this. Basically, you're going to be turning in your assignments to my website, which notifies me when you've uploaded, and I can download it and start looking at it. Whereas if I were to use the university servers, I'm not allowed to have you guys upload things and do some things like that. So we get a little more freedom here, which is kind of nice. But the other thing that's nice about this website, I've been teaching Revit here at the university since 2011, basically the spring class. And I've actually been teaching here since 2009. Before that, I taught digital methods which is now computational methods. But at that time I was doing basically Grasshopper, we were doing scripting, and we were also working in Rhino. And then when Nick Sinsky came here, he took over the computational methods and has taken that course on. And then I've been very focused on, basically getting all, this class and other classes up and running on Revit. So I've taught not only this class, which is basically building information modeling, but I've also taught computational practice. I did some workshops for that one spring. And then actually last semester for Comprehensive Studio, I also did some workshops for that class as well. So every now and then I pop in and out of other classes and kind of get people up and running. So you might see me from time to time going into other classes. One thing about this website is everything that I'm going to post for this class will be under the classes section of the website. Obviously there's nothing there right now because we are just starting. But essentially what will happen is throughout the semester, if I go to an archive section, I've archived all of my classes that I've taught all the way back down to actually the 2012 spring semester, because the fall 2011 semester was when I first started, and I wasn't recording the classes at that time. And then I finally got on board and thought it would be great to be able to record these and have tutorials. So you have actually access to a lot of different classes if you really want. But essentially the way that the classes section will look will eventually be what you see here on this archive screen. When you click on classes, there will be kind of a short summary of what we did in the class. There'll be a little icon or a little thumbnail image off to the left, and then a title for the class. When you click on the thumbnail, that will bring you to the class 1 page or the class 2, whatever one we happen to be in. And again, I give a summary. But I also give links and also downloads. So any kind of downloads that we might have had in class will be available on this website. So you'll be able to download the files as needed. And then there's an embedded link to to my YouTube channel, which is where I'm actually posting all of these videos just to save space on my server. I put it on YouTube, and then we just kind of embed it to that. But essentially, when you hit play, that will play the whole entire class, and you can make that full screen and follow along. So this is basically your main resource for this whole entire class. You'll want to come back to this site and keep up with it as much as possible. When you first come to the site, you'll see a What's New section. And I just have a running catalog. Basically whatever's on top is like the newest thing I've done. I just try to give, whenever I've posted something new to the website or added something to it, I just try to give a little date and explanation of what I did, just so you can follow along and know that there's something new that's been part of the class website. There is a resources section. I'm not going to go through all of this at the moment, but you can peruse through these different resources and find various articles and papers, approved web links. I basically have links to other sites that either I follow or I might frequent once in a while. And I think they're great sites for either Revit content or actually looking at what other people are doing with the software. So you can visit that as well. And then there's some things about keyboard shortcuts and Revit math. Under the public access section, doesn't really make a whole lot of sense anymore. I used to have this whole site kind of locked down with a username and password, but I figured since everything's on YouTube, it didn't make a whole lot of sense to do that. So this used to be the free section, I guess you could say. But basically, under the public access, this is where you can find my professor contact page, which essentially, if during the whole entire semester, if you ever have any kind of questions or comments or whatever, you can always fill out the form here and email the comments to me, and I'll get it right away and I can respond back to you. You can also go to, let's go back to the BIMethods main page. If you click where it says under the What's New, or we can actually go to classes, there should be a PDF syllabus that you can open up. And this is the syllabus for this class that's brand new. One thing you'll see up in the top left corner is, again, my name's Professor Rhos, but I have 3 email addresses. And I'll explain that here in a little bit. But essentially, I've got the UNCC email, which is obviously for here. Then I have a digidesign@att.net. That's a personal freelance business email that you can reach me at. And then the other one is j.row@fwagroup.com. And basically, that's where I am during the day at all times. So essentially, one reason we meet at 6:30 at night on Tuesdays and Thursdays is I'm a part-time lecturer here at the University of North Carolina, Charlotte College of Architecture. But during the day, I'm actually working full-time at the FWA Group Architects here in town. I've been with them since 1999, and we specialize in basically doing higher education buildings. We did the student union. We did a residence hall, Hunt Hall, that's over here on campus, and we're actually doing another one that's going to be starting construction soon. And we've done work all over, not only here in North Carolina, South Carolina, and then all the way out to Colorado as well. So anyway, my full-time job is working at the FWA group, and then I'm here at night. So the way that this class is going to work, you'll kind of see the Tuesdays and Thursdays, we're going to meet here from 6:30 to 7:45. And essentially, I don't really have an office here. And so what I do is for my office hours, I just stay an extra hour if need be, to help you guys out on whatever you're working on. Obviously, throughout the semester, that will be probably more prevalent as we get into more projects and more into Revit. But essentially, my office hours would be 7:45 to 8:45, for instance, if I need to stick around and help you guys out. So feel free after class to always ask me questions, and even if you need help not only with this class or if you're using Revit for another class, I can always stick around and help you out. So that'll be kind of how I'll treat the actual office hours. And like I said, I also have a freelance business where I just kind of do random Revit type of projects. A lot of contractors come to me that need Revit models, and I'll just kind of do those from time to time, or just get into renderings and things like that. For this class, if you scroll down on this syllabus, just on the first page, you'll see some important links section. Obviously, there's the class website that I just talked about, but there's a couple other links that you'll need to know, and one of them is about the free Autodesk Revit software. I don't know if everyone knows this, but Autodesk nowadays, if you're a student or faculty, all their software is free. So if you go to their website, which is you can go to this link, which will actually take you directly to Revit. I'm going to back out of that for a minute and just take you to, if you just go to www.autodesk.com/education, that will actually take you to their education home where you can sign up. You basically just have to fill out a form, and then they give you access to all the software. And essentially what happens is when you download the software and install it on your own computer, you basically have it, I think, for 4 years until it expires. And obviously every year I think you can renew it and extend that expiration date. But when you go to that website, if you go to the section here where it says free software, that will actually, when you scroll down, you'll see a bunch of different icons, and then you'll see all the software that is available. So obviously 3D Studio Max, AutoCAD, and what we'll specifically, like I said, be using for this class is going to be Revit. Now, if you look here in the middle of the screen, there are, let's see, 1, 2, 3, 4 different Revits. There's just Revit, there's Revit Architecture, there's Revit MEP, and Revit Structure. If you're actually buying the software, if you're a structural engineer, you'd probably only buy the Revit Structure package. If you're MEP, again, you do mechanical, electrical, plumbing. Architecture, you might just do architecture. The one that's just called Revit, that essentially is the Revit suite, which means it has Revit Architecture, Revit MEP, and Revit Structure all embedded within it. So that one's obviously a little bit more money, but since this is all free to you, what I would do if you're going to be downloading this for your own use on your computer is I'd actually just download the Revit suite so that you have all access to every part of Revit. Essentially, when you get to the download page, they'll want you to eventually log in, and I'm not logged in, but down here where it says, let me see if I can log in here anyway. So you'll have a username and password once you sign up with that form. And then when you get to this page and access it, it'll start to allow you to select the free software that you want. And it wants you to choose your version. You'll see here that it's a little bit small on the screen, but you can see you've got a choice between Revit 2013, 14, or 15. So for this class, you're going to want to download 14. especially so that you can also utilize your files with any of the software that's available on the school computers. One thing about Revit to keep in mind is kind of like InDesign. I don't know how familiar you are with InDesign, but essentially Revit 2015 can open up any file from Revit, whatever 2008 and on. However, if you're in Revit 2014, you can't open up Revit 2015, and once you open up something in Revit 2015 and it upgrades, you can never downgrade it again. So essentially, if you were to open up one of your files that you're working on here in the computer lab in 2015, it would automatically upgrade when you save it, and then you try to open it up again here, you're not going to be able to open it up on 2014. So just kind of keep that in mind, for those of you that want to look into 2015 and so on. I think you can install 2014 and 15 on your computer if you really want to look at the difference of the different parts. But essentially, just keep that in mind. That's very important. And it's also very important when you're in an office, because when you're working on a project, everybody has to be on the same version. So even when we're currently working on a residence hall right now, so our structural engineer has to be on 2014, our MEP has to be on 2014, and we all have to be kind of coordinated together. And one person can't decide to upgrade, otherwise we all have to upgrade. So it's one of those things you have to coordinate. The other part of this class is going to involve what's called Dynamo. Anyone here use Grasshopper for Rhinoceros? Everyone probably had a little bit of experience with that in computational methods. Basically, Dynamo is the Grasshopper of Revit. So essentially everything that you could kind of do in Grasshopper for Rhinoceros, you can actually do with Dynamo and even more, because Revit has a lot more built-in capabilities that are more parametric and data-driven, whereas Rhino, basically Grasshopper made all the parameters for you, and you had to do a lot of programming in order to make anything parametric in Rhino. There's a lot of inherent capabilities of Revit that already has that built in, so Dynamo just kind of enhances those capabilities and allows you to do a lot more components. One thing to note is with Dynamo, just like in Grasshopper, it's kind of this beta version of kind of the scripting software that basically is open source, so people are constantly writing new little plugs for it. And so every day or every week or so often, there's kind of this new upgrade or this new version that comes out. And one thing to keep in mind is we're going to be kind of only on one version throughout the whole entire semester. We're not going to try to keep up with every little nuance and upgrade that comes out with Dynamo. So when you go to Dynamo, if you've installed Revit on your own computer, you're going to want to go to the this Dynamo page, and this is actually at, I'm going to zoom in again on this. It's a dynamobim.org will take you directly to this page, and there's also a link that takes you directly to the specific Dynamo version that you need to download. So let me get back on this. So back on our syllabus, this link right here, if you click on that, is actually going to automatically make you download the version of the Dynamo that we need to have, for this class. So on that website, that's actually found under downloads, and then they have kind of the most recent downloads will show up here on the bottom left, but there's a little button here that says view previous builds, and we're actually going to be using Dynamo install 7.0. So that's the one that the link on the syllabus, if you just click on the link on the syllabus, it'll take you right to that and download it for you, and then you just need to install it. Essentially, Dynamo has to be installed after Revit. So once you've done Revit, then you can download Dynamo and install it. And basically what it does is it makes it as an add-in, a little plug-in that we can utilize. And I'll go into a lot more of how that's going to work a little bit later. Before I talk more about the syllabus, I wanted to give just a little brief explanation about BIM, which is Building Information Modeling. And also I call this class, you'll notice kind of in the class website, it's called BIMethods instead of just Building Information Modeling. Building Information Modeling is the official name that the university gives it. I call it BIMethods because I actually kind of teach this class more as a exploratory and detailed design process. where we're going to be really pushing the boundaries of Revit beyond what you would ever encounter in an office, probably push the boundaries more than what you might encounter in other classes that you might just have kind of a brief introduction to Revit. We're really going to be looking at kind of finding really efficient ways to model, and we're going to be scripting a little bit with Dynamo and making things more efficient and parametric so that everything that we do is modeled once, and we can program it to do different things, and then we can actually make it something where we can explore different design options without having to do a lot of excessive remodeling. But before I can really talk about what we're going to be doing in this class, I kind of have to talk a little bit about the conceptual framework of building information modeling. And I'm sure a lot of you have heard the term and probably know a little bit about it from just your experience and other research. But essentially, just kind of as a quick summary, basically where we started as architects, let me get rid of this little magnifying glass, back before computers even came out, is essentially our design process was really more about, we had a sheet of paper in front of us, we drew a floor plan, we might have drawn some elevations, we're kind of thinking about our design. You may have done a little, model, you've probably experienced this process in Studio where you've kind of explored like a chipboard model to kind of further look at your design. But essentially everything that you were doing was on paper. You were basically, drawing your floor plan, and then you had to start thinking about what it would look like in elevation, and then imagine what it would be like if you cut a couple sections through it. And each time you had to generate this from scratch every time and kind of think about it in your head, how all those pieces were going to go together. And especially in an office setting, when you're doing construction documents on a project, you're going to have probably 100 different drawings just to explain your building and how it's going to be built. So if you make a change to a section, or you decide that in your elevation you need to raise the roof a foot or move a window, or these kind of simple ideas, or even something major, every time that you did those little changes, you had to go back to all your different sheets that had your floor plan and your other elevations and sections, and you had to update all of those as well to coordinate with all the changes that you did. So it was kind of a tedious process to make a change. You had to do a lot of erasing and kind of follow your process through. And then you also had to use a light table once in a while to kind of coordinate with other, basically your structural engineers and your MEP consultants. You basically had to overlay to, make sure you didn't have any ductwork going through a beam, or something like that, or you were kind of coordinating where all these components were going. With the introduction of computers, and here's a real old picture of a computer from FWA a long time ago, before my time. But back then, these computers were huge and they didn't do a whole lot. But essentially, with the introduction of CAD, and everyone's kind of familiar with AutoCAD, and utilizing that probably more often than you're actually doing your hand drawings. Essentially, all that CAD did was it made your drafting board into a computerized drafting board. So you were still doing all the same things. You were still drawing a plan, you were still drawing a section, you were still doing all of your elevations, but now you just did it in a computer screen on a separate file, or maybe you had all your different drawings on the same file, but essentially all your parts and pieces were still separate. And so again, if you had to make a change, it made it a lot easier because you didn't have to erase so much, but essentially you could quickly make a change or copy things and mirror things a lot more efficiently. It made your process more efficient, but your kind of the connection between all the parts and pieces were still separate. So again, if you made a change, you had to definitely follow it through all the different files. With the more advances of computers and the computer hardware getting a lot better, 3D modeling software came out. So obviously everyone's familiar with SketchUp, and even 3D Studio Max. Back a long time ago, it was Form Z. There's been all these different kinds of 3D software out there that really allowed us to start to visualize the building in 3D space, and we could still look at it and play around with it and come up with our design options. But that 3D model was still separate again from all of our drawings. So we would sit there and model everything, and you probably experienced this in SketchUp or in Studio or in other classes, is you model your basically your model in SketchUp, but then if you want a floor plan or a section, you have to make an extraction, then take it into CAD and add more to it, to make it look good, and so on. So again, if you made a change in your floor plan in the CAD drawing, you had to go back to your SketchUp model to make that change too, if you really wanted everything to coordinate. So really with BIM, the only difference now is that we have this underlying database that is part of the model. And so you'll hear everyone in building information modeling and Revit always talk about the model. And what the model is basically this 3D component where you've drawn everything, you've modeled everything, and from that you can actually extract all of your floor plans, all of your sections, all of your elevations in real time, so that when you move something in 3D, so if I were to move and redesign this wavy wall, I could immediately go into a floor plan and it's already updated because it's all connected. And that's what Revit is, and that's what building information modeling is everything is connected together so that when you make a change in one place, it's happening in all of your other different drawings. And you no longer have to worry about catching all the different changes that you made through 30 different drawings or so on. And you also have this information component. So that's the I that's within BIM. And that information component is something that can be data that is either drives the design or it's data that actually is extracted from the design. So you can actually make parametric data that is programmed into the model actually change and morph and kind of experiment with different components, or you can make one component and, like, for instance, a window could have different sizes just by inputting different data, and that data would drive the changing of that model. Or you could actually extract from the model, something simple as like a door schedule, where you could just say, I want to know how many doors are in my project and where they're located, what floor, and you can come up with this whole entire database spreadsheet that gives you all that information. One thing that is kind of out there, and this is an old slide, actually a lot of these are, but if you look at this pie chart, essentially, with Revit, a lot of the books that are out there, and it's still kind of like this these days, is all of these books are really driven towards the industry. So that pie chart there is talking about what amount of time you spend in the actual profession working on a site analysis, working on schematic design, then design development, and then you see how much of the pie chart's left where all of your focus is going to be on construction documents. And so everything that's written, not everything, but majority of the books that are out there written for Revit are all based on getting you to construction documents and how to make construction documents within it. So when Revit first got introduced here at the university, a lot of the professors were real hesitant about it because everyone saw this as how the books were presenting it. It's this like construction document program that just makes it more efficient for you to do those documents. Whereas if we're looking at this, what we do in the classroom, this pie chart shows, what level you're going to be working typically in site analysis. You can see the large amount of the pie is devoted to schematic design, then design development. Then you got a little chunk that you might get into construction documents depending on, what class you're, taking. But the way that I teach this class, and one of the books that I'm going to recommend here in a minute, is really focused more towards the classroom. And it's mainly because I like to see Revit help you explore your schematic design, start working with, immediately in site analysis and also throughout your whole entire design development. In the office, when you get into the profession, there's a lot of firms out there that are still debating on when to introduce Revit into the process. And so they'll say, well, we're still going to use SketchUp for schematic design, and then we're going to still use it through design development, and we're going to do CAD. And then when we get into construction documents, then we'll implement Revit, which is, just completely negates the whole reason to be in Revit for the first place, to be efficient. And at our firm, we just do Revit from the very beginning. And it really helps, throughout the whole entire process because you can really do things a lot more efficiently. You can explore things quicker. Plus, you can represent your project in a very accurate way quickly, to the client in a fast-paced, kind of moving, schedule that usually happens in the profession. Before I get into that, let me talk about the recommended text. I don't require a textbook for this class, but if there's one textbook that is out there, let's see, I'm frozen up. Come on. Great. If there's one, I can go to the syllabus here. There's one textbook that I would recommend. It's over here in the syllabus. It's actually called Mastering Autodesk Revit Architecture 2014. And you're actually lucky we're kind of in 2014 because there's a new version that just came out that's 2015, and so obviously that book's going to be new and more expensive. The 2014 you can probably find used and so on. But I was going to show you where you could find it, and it looks like there we go. Well, it doesn't really blow up that big, but essentially it's a Wiley publication, and the official title again is Mastering Autodesk Revit Architecture 2014. And this particular book I have actually been following since at least since I've been following since 2010. Essentially, this book is more geared towards that pie chart for the classroom, where it's trying to tell you what ways you could actually use Revit in the classroom. But also they have a lot of experimental ideas and things that were embedded within this book, that a lot of what I'm teaching is kind of based on some of those early items that they were actually talking about in the book. They don't expand onto a lot of things in detail, but it is a good reference book that you can kind of look at from time to time. And if you can find it used, I think here it's brand new, it's $70, but I'm sure you can find it on Amazon for a lot cheaper and so on. So just if you want an extra reference guide, I'd recommend that book more than any of the others that are out there, because this one's really geared towards how we want to use it within the classroom. Now, talking about what we're going to be doing in this classroom, this isn't exactly what we'll be doing, but this is kind of what we've done in the past. We've worked on various projects, anywhere from a 4,000 square foot home to a parametric bridge to parametric towers that were 120,000 square feet in area. We've done let's see, a couple observation towers. Last semester we did a metro station. So every semester I try to change the type of project that we're going to be doing. But essentially what we do throughout this class is I'm going to be teaching you in a tutorial fashion a topic. We'll go through some exercises of how to make it work. Then the homework assignment will generally be, either complete what we did in class or do it in a, slightly more expanded version of it. But everything that we do will eventually be working towards kind of this final project. There'll be kind of a check-in moment at midterm where I'll kind of collect kind of where we are with the project and give you a grade then. I basically give grades out at midterm and the final. But essentially all of these tutorials that we do are going to build on how you can start to put together your project, and I would try to, as we go through the class, we'll be constantly building our particular project. This semester we're going to be working on essentially an observation tower that's going to have kinetic panels or kind of components that are going to be part of a facade system or a roof canopy. So there's going to be these actual components that could actually track maybe the sun movement or some other component that we might want to explore. And then it's going to have eventually some other building program components to go into it, and probably some kind of metro station component that will intersect with it later on in the semester. We'll get into a lot more development of that. But essentially working from day one in Revit, we're going to be exploring the conceptual design environment. So this is what you kind of see on the screen here. A lot of people, when they look at Revit or have seen it in the past, they think it's a very rigid program for some reason. And a lot of it has to do with the way that the tools are named. Once you open the project environment, you basically all your tools say wall, door, window, stairs. And when people look at that, they say, oh, well, if I want to draw a wall, I have to click on wall. If I want to draw a stair, I have to click on that icon. And what I like to teach here is that we can actually, if we understand what those tools are doing, we can actually use them beyond what their initial intention was, and we can actually come up with a lot of more creative ways of doing things within Revit. But within the conceptual design environment, we can really get into a lot more free form and a lot more complex geometries that you're probably more familiar seeing when you get into like Rhinoceros. That's kind of the first thing you do in Rhino. You draw a couple curves and loft them together. We're kind of going to be doing that within Revit as well. The nice thing about this, though, is that because Revit has that underlying database and that data structure that's within it, we can actually program as we're doing our components and our complex freeform, and we can actually explore our designs in a lot more efficient way. So for instance, on this slide, you'll see that curve up at the top has 4 points. And over to the left, there's a dialog box that has programmed parameters in it that drive the XYZ components of those points. then essentially that curve is modeled one time. The points dictate that this curve could change in infinite possibilities. So we might pick 4 different ways that it could change, 4 different ways the curve might look. We could put them together, and again, it's only the same curve, and then loft them together, and then we can explore by changing the curves, different forms, and also make that form parametric. So that form that's down below is actually modeled only one time, and it's just the data that starts to drive, how we want to explore how it's going to look. We can get a little bit more complex with all of our components, and we can actually make one adaptive component, and we're going to do a lot with adaptive components within this class. Down at the bottom left, this is one component that actually makes, if you look to the right, that particular facade. So that component is programmed with all that data up at the top to change based on some kind of formula that says there's basically this point attractor. You see this point right there. When this point is further away or closer, it dictates whether or not this oculus gets bigger and whether or not the materials change and get thicker or wider or whatever. And essentially, so you can see right here when there's basically this point attractor that points really close, and you can see all the different ways that this component is changing. And then when it's the point is further away, this same component is actually just changing to this. So what's nice about that is we can model one thing. Yes, we can set it up for to react to different things. It's going to take a little bit of time to program it, but once you program it, you can apply it to any kind of surface. It doesn't just have to be the straight surface. It could be one of those complex surfaces, and you can really explore how your design looks without having to excessively remodel this component over and over again every time you want to make a change. So you can imagine if you had to model even that facade in SketchUp, you would have to sit there and make a new component for each little variation that you want to do, and that's a very tedious task, whereas this could be done in one class time, and then you could kind of move on and get a lot more complex. There'll be moments in this class where we might actually do some bug models. So you can see this actual cardboard model, very simple kind of things just to get you to look at how we can form and work with materials. And also occasionally we have to come out of the computer just to have that gravity effect on our models to know that you do have to have some structure. Can't always be this free-floating thing. But then we can take that and put it back into Revit, just using some digitation techniques, where we can actually put in XYZ data into points and then actually kind of digitize our model into Revit and then explore it even more. So eventually you could kind of put all those things that I just showed you together and make very complex structures that are parametric. So this bridge project actually was a parametric structure that could actually be put anywhere, could have any length, could have any kind of change in height from one side to the other, and it could also change its path orientation, so it could kind of curve to the down on the screen or up on the screen. And then same thing with the canopy structure that was also parametric. What's nice about that is all it took was there's actually 3 or 4 components here. There's the bridge component, the pathway, then there's the tensile structure, there's the main structure, and then there's that that particular panel that actually makes up that kind of canopy structure, kind of give it that tectonic look. Those 4 components were only modeled in Revit and then applied to this complex surface, and then you could sit there and explore and move these things back and forth over different lengths and so on, and you get different variations without having to remodel it every time. So all of this is done with adaptive components. Again, you could change the adaptive component and make some more parameter tweaks, and you get this other bridge from that same kind of form. So there's all these different things that we can do within Revit in this data-driven design concept. Some other things real quick in schematic design. We can do things that are real simple, just like with massing. So here's just a tower massing exercise. But because it has data, this database behind it, we can actually track what the square footage of this particular intuitive mass is as we're sitting there pushing and pulling on the form and taking out voids and so on. So if you happen to have a program, for instance, in Studio you always get a program that says your project is going to be 30,000 square feet or some kind of requirement. You can sit there and play around with the form of your schematic design shell but you could constantly track it and have real data that would actually tell you whether or not you're within the right scale of your project. And so from a very early schematic design phase, you could be utilizing Revit and also enhancing it with that data, information that's behind it. You can also make this data drive the design of those towers. So in this case, there's actually parametrics that are tied to the towers that make it twist and come up with different forms. And you can sit there and play around with just moving points around without having to, again, remodel these things over and over again. One last thing is, again, we can take that facade idea or that adaptive component, and you can apply it not only to canopies, but it could be applied to a facade. You could get these real complex looking structures with just making one component that eventually repeats over the surface over and over again. One of the things that we're going to be getting into in this class will be the idea that these adaptive components can actually be tied to some real world information. So we could actually have this one component, and you can see the two, basically showing two different ways it changes up there in the top left. That could be applied on a surface, and then based on where the sun is or what your heat load is on a particular part of the facade, this component can change and be more kinetic so that you can really explore and have a more efficient design of your building, that's actually tied to real context or real information. We're not going to take it into a very in-depth study, but what we're going to do is talk about how we can make these components move kinetically and how it could maybe attach to the sun or follow the sun, so that you can tie that to a sun path diagram and have something that actually makes a little more sense and gives you a lot more variation across a facade. So you can see this particular tower has a lot of variation that's made with just that one component, which is kind of nice. Not really going to get into too much of this stuff, but essentially, we can model all the way down to the very detailed level in Revit, because Revit is meant to be construction documents eventually. So we're going to be modeling throughout this semester in a very detailed fashion, because it's very important to know how to model detailed in Revit so that essentially when you cut your section, you don't have to draw anymore. You've already got all that detail there, and you're ready to move on, and you don't have to spend all that time adding in extra lines and extra components to make it look like that. We can obviously, I just talked about, we can tie things to the sun. You have a solar path diagram. We can work with site topography and so on within Revit. One of the important things I've talked about is the parameter. Everything in Revit is all about the parameter. So this class is really going to be parametrically driven. Everything we do is going to be programmed in some way, even down to the 2D component. So you can see here, this is just a simple coping detail and a sunshade. That's just a 2D element, but these 2D elements can also be parametric, and we can program it. So in the office, we've got to put copings on all of our parapets. You've got to have that detail. But I only have to draw this coping one time. It looks the same all the time, but it's going to fit on different walls, and it might have different heights, it might have different widths. And so instead of drawing this over and over again because I have different conditions, we can just program this one component to change and adapt to the different ways that we're going to eventually apply it. So another thing about Revit is, we'll get more efficient once we understand how we can program it, so that we don't have to keep making things over and over again like you might have to do in SketchUp. Just a simple example would be, in SketchUp, if you have a window that's 5 foot by 10 foot and it has a horizontal mullion and a vertical mullion, well, then you might have another window that's going to be 5 foot by 4 foot. What do you have to do? You actually have to do a save as of that component, and you have to remodel that or make the changes on that, and you have a whole other separate file that has to deal with that other new window. In Revit, we could just have one file that's just going to program it to say, okay, I can make this window change in infinite possibilities, and then I never have to make this window ever again. I can just change the width and the height. So it's really quite nice. And even these 2D components can eventually be extruded and really detail up a facade or any kind of component that we want to do within our modeling capabilities. And I'm not really going to talk about too many other things here, but other to know that everything we do is also going to be talking about how we represent our model. And what we're doing is how we're going to represent it not only in a photorealistic way with renderings. So we're going to get into material application, lighting, how to render. Revit has its own render engine built in it. So all we have to do is render. We can actually render to the cloud. One thing that's real important is that, Autodesk education website that I gave you, and I told you in order to download, you have to have a username and password. You're also going to need to at least register with that website and get a username and password, because once you're registered with that website, we have free access to their cloud. Their cloud is a big data farm somewhere, I don't know where it's located in the world, but it's just this huge building full of servers that you can send your renderings directly to the cloud for free and get them back instead of waiting. I don't know if anyone's ever done renderings before, but it could take, interior rendering could take like 10 hours depending on what kind of detail you have, what type of materials and lighting, and of course how big it's going to be. I can send it to the cloud and get it back in 15 to 30 minutes sometimes, depending on the backlog of how many people are in line in front of you. But we have that free access in this class, and as a student, that you can actually start utilizing that cloud, and we'll get into how to use that throughout the semester. What's nice about that is we can send multiple renderings at a time, and they'll come back to you, in literally probably within an hour, which is real nice. Revit, we can, like I said, we can model anything, so it's not just going to be limited to buildings. So obviously, like I said, we're talking about modeling facade systems and canopies and very tectonic structures that are going to be part of this class. And you're probably familiar or have seen the Solar Decathlon project. I did workshops for them. They had to actually do all of the drawings and the representations and renderings directly from Revit when they were working. I think at that time that was Revit 2012, if I'm not mistaken. But the Solar Decathlon project was all done in Revit as well, all the way down to the construction documents and also the way it was presented. So a couple of things I need to just talk about, and then we'll kind of open up Revit and just at least get navigated into how we move around within it. Is I just want to talk about some of the nuances of the class, just get the official stuff down that's in this syllabus, and also talk about it a little bit more. Essentially you can read the course abstract. It's kind of real brief what I just talked about in the last hour or so. But essentially this class is going to be broken into three different parts. I used to do 4 and realized it's just too much to try to cover in a semester. It's really going to be 3 parts. The first part is going to be all about this programming of the parametric kinetic part. So we're going to be getting into Dynamo and the conceptual design environment at a very part level at the very beginning. And then we're going to move into how to apply that part and connect it to these adaptive complex canopies and facade forms. So we'll get into making these complex components that will take us literally to probably the midterm. And then after that is going to be all about how to make our project modeling in the with parametric components in the project environment, as well as still utilizing that conceptual design environment to really put our project all together. Some little things to just talk about. I've talked about the software, what we're going to be using in this class, but there is no prereqs to this class, at least at this moment. So although a plus that some of you know Revit, you don't have to have any previous knowledge of Revit or actually have ever opened it. I'm going to start from we're going to walk through every little tutorial in a very hands-on way to get everybody up to speed on what we're doing. And most of the people that have probably used Revit are probably not going to have used it the way that we're going to be using it, at least in the first couple parts. One thing is essentially everything, since this is a computer-based course, all of our assignments are going to be in Revit. You're going to be turning in Revit files to me, and then I'm going to be looking at them, opening them up, kind of grading them as we go throughout the semester. One thing I just want to make sure that you guys are aware of, and I'm sure everyone says this in every single class, is that you need to make backups of all of your files as you work. Because I'm not going to take any kind of excuse that you lost your file or your file crashed and you lost all your work. Revit makes backups as you work, and I'll explain that later in another class. But there's always backup files that are being made, and at the same time, you shouldn't be just storing everything on a USB stick. I hope you have a laptop or another external hard drive somewhere that you're also taking your files and putting them on that as well. That should be across the board on all your classes, because I don't know how many USB sticks you've gone through, but I've basically killed about probably 16 within the last 5 years. These things aren't meant to have things excessively read and write to them. So a lot of people, they plug them into a computer and work off of them. They're not made to do that. They're made to transfer files from one computer to the other. And I think after a while, they just get tired of reading and writing to a file, and eventually you just can't read. They just don't work anymore. And so I've burned out a lot of those things, especially when you get up to the ones that are above 4 gigabytes or so. They seem to die quicker for some reason. So anyway, please make sure you're backing up your work. Of course, you can use a USB stick, but I would definitely make sure it's on a hard drive somewhere as well, because you never want to lose your schoolwork and all your things that you're going to have to do for a portfolio one day. Like I said, you have software access. I went over where you can get all that already. I've talked about the recommended text. And then the class website. One thing I just want to iterate here real quick is that even though I post the class afterwards, and essentially just to let you know the process, when I get home after this class, I'll convert this video over to a YouTube video and then upload it. And it usually takes about, depending on how quick YouTube is allowing things to get uploaded at that time, it could take about 4 hours for it to finally get up on the site and also be converted and all that kind of stuff. So the video is not going to be ready right away, but it will definitely be ready probably by the time you wake up the next day and have to start worrying about your other classes, but you'll be able to access it. One thing I just want to note is that it's because I'm posting this online, this isn't an online course. So don't think that you can't come here and sit and you can actually just stay at home and kind of follow along, after a while. You have to be in this class because a lot of times we're going to run into problems. You might run into a problem while you're working on something, and I'll actually, occasionally pause the video to go around to kind of work out these problems so that we actually keep the class moving. If you're trying to follow along on a video, at home or something like that, it's real hard to, you're going to get, you're not going to get all the opportunities to ask questions and also to, get the experience that you need. So please don't abuse that. I know it gets hard towards the end of the semester. People start, I notice, kind of not coming to class. And your grade is based on, if you go back to part one, this distribution here, 30% part one, 30% part two, part three is 30%. The other 10% is your attendance, preparedness, and timely resolution of all your assignments. So your turning in of your assignments and you being here, is very important that you get there, because that could actually make or break a grade. If you could have work that was all A quality work, but if you missed all the classes or turned in assignments late, you could end up probably with a B. When time you factor in that 10%. So it's real important that you're here and you kind of follow along with what we're doing. That helps me also gauge the pace of the class. So I definitely need to sort of have the audience here so that we can kind of keep on moving. The other thing here is I've got a schedule of topics that you can kind of look through. This is very tentative. I want to stress that. I've got to outline essentially what we're going to be doing or what the focus or the topic might be from a day-to-day basis. So I've got the class number and then what the date is, whether it's a Tuesday or Thursday class, and what we're going to be doing in that class. Based on the way that we move, some classes might take longer than others. So some of these topics might, get pushed to other days, or, things might get shuffled around. So this will get updated throughout the semester, so just be aware of that. I try to keep the class current and, not try to skip over things if we're, running out of time. I want to make sure we cover everything. But this will give you kind of an idea of what we're doing, and then some of the topics that we'll be getting into. It's not all the topics, but there's other things that are embedded within these headings. And then obviously at the very end, there's all the typical boilerplate stuff. We've got definitions of what it means as a graduate student. The next page is as a undergraduate, what it means to get an A, B, C, D, F, and so on, is if you read that definition of what it means to get an A or a B or a C, and you can sit there and look at your work at the midterm or even at the end of the semester, and you feel that your work fits those definitions, you're most likely probably going to get that grade. You know, a lot of what I'm grading is based on what's in these particular definitions. So you've probably seen these definitions in other classes, and you can kind of take notes to what it means. And then, of course, I've got the attendance rules, and then all your boilerplate, you know, university references. That I don't know if they should be up to date. And then, of course, I have more of the disclaimers in there as well. So that's really the syllabus. You can peruse through that and take a look at it. And if you have any questions, feel free to, you know, email me and ask me, you know, whatever, and I'll try to respond. I try to respond to your emails even though I'm at work during the day. They pop up right away, and so I will usually reply in a timely fashion. I may not be able to get to you right away, but you know, throughout the day, if you have something that you're stuck on and you know, it's real important, you know, I'll probably be able to answer it and at least keep you moving if you're working on things. So don't hesitate just because you know that I'm at work. Go ahead and send that comments to me or the email, and I will respond. One thing to note is if you send me an email to anything but the UNCC email, I'll probably respond to you quicker because I'm usually sitting in front of a computer here or a computer here. So essentially those emails are always up. I do have the university one up, but you know, it might get lost in that translation. So let's go ahead and just get acquainted to Revit and what you're going to kind of see as we get through or start moving through this class. There should be an icon on your computer that already says Revit 2014. If not, you can go to the Start button here, and you go to All Programs, and it'll be under the folder called Autodesk. And then you'll see Revit 2014, and then you're going to open the one that's just called Revit 2014. I want to note something here. You definitely don't want to open anything in what you see here as the Revit Viewer. It says Revit Viewer 2014 and it's right underneath that other icon. And if you accidentally click on that, what happens is you can open your file, you can work in it, you can do all kinds of fun stuff. You just won't be able to save. So I've had a couple students, they did a lot of work and they were working in the viewer and then they kind of lost it all. Or if you do that by accident, let me know and I can tell you a way to make it get into the regular Revit program. But essentially the viewer's there so that I can let my boss get into my model and look at it and do whatever they want, but I know they're not going to like mess it up and start moving doors and windows around and those type of things. So just make sure you're always opening up Revit 2014. And when you do, you'll get to this essentially this splash screen. It'll say Projects and Families, and your screen will look different than mine every single time because these thumbnails under the next to the projects and next to families, they're going to show you what the most recent file you had open is going to be shown here. Kind of your last 3 files each and every time. That'll probably not work. The fact that you always have to log in on these computers is probably going to show you what you see on the screen here every time. But if you're working on your own computer, whatever you had open last is going to be the first icon here, so you could actually just click on it and then you're back into your file. We'll be working in, essentially, Revit is broken into 2 parts. Actually, it's 3 parts, but basically 2 main parts is the project environment, and then there's the family environment. The project environment is where you do all the main modeling. It's the main model, it's your building, it's whatever else you're going to be putting into your project. Your families is your component. So all the individual components that make up your model is basically then put into the project environment. So the project environment is kind of made up of various families that are put together, and then that makes your whole entire building or your project file. Families can have other embedded families within them. So you could have a family with another family and another family and so on, all part of that file. Just think of families as, if you're familiar with SketchUp, that would be the component. If you're familiar with Rhino and AutoCAD, that would be like making a block. I don't know if you guys have ever gotten into that, but essentially that's what a family is. It's a block or it's a component that is going to be part of your project environment. So it is a separate file, and then you have your project file that's also a separate file. Let's just open up the project environment. In order to do this, you should see on your screen this option here called Architectural Template. Just go ahead and click on that, and that'll take you directly into the Revit environment. Now, your screen, when it first pops up, you probably have, let's see if I can get it to dock, something similar to this, where you can see what's called the project browser down below on the left, and then you have this properties dialog box that's up here on the top left as well. What I like to do is take the project browser, and you can drag it, and I like to dock it, let's see, off to the right here. There we go. And the reason for that is throughout class, this is how I'm always going to have this set up, is that when we're working on a project, this properties dialog box, and you can see all the information that's in it. There's a lot. There's even a scroll bar. Depending on what tool we press, so if I were to click on architecture and then wall, for instance, you can see how the properties dialog box changes. So with each tool that you click on, that dialog box is going to keep changing. And there's a lot of different inputs that are part of that dialog box. And if you have it all scrunched over to the left-hand side, you have to do a lot of scrolling up and down, and it just gets kind of annoying. Also, when you're working in the project environment and also the family environment, this project browser is going to keep growing and growing as we add more to the project. So again, that'll make it so that we don't have to keep scrolling back and forth and so on. Some typical things here, if you're hovering over the main part of your screen, if I just take the mouse wheel and wheel it back towards me, that zooms out. If I wheel it towards the screen, it zooms in, kind of typical AutoCAD, anything you've seen on other programs. If you hold in the mouse button or the scroll button, it allows you to pan. So if I'm holding in, I just press down on the scroll button, and then I can move my mouse around. That'll allow me to pan around on the screen. You can also use these scroll bars here. There's a little up and down arrow that'll allow you to pan, and so on. If we go to View, so up here if you look at the top here, let me just introduce the menu here. You have menu ribbon bars. So if I were to click on Architecture, you see how the tool ribbon changes. It's kind of typical what every program's doing these days. If I click on Structure, you can see how you have another set of tools under that ribbon. So that main menu heading at the very top has basically all these other tools that are embedded within it. So if I were to go to View and hit here where it says a 3D view, I just want to click on that. It's going to take us into a 3D view. And the reason I want to get into that is I want to get into some other navigation techniques. When we clicked on View and 3D View, if you look at your project browser off to the right, you'll see here that a 3D view was added, and if I expand that, it says 3D view and it's highlighted in bold. Your project browser is how you navigate through Revit. So it will navigate to different views where if I want to look at a floor plan, I can double left click on level 1 and it will take me into a floor plan. If I go back to the 3D view and double click on that, it takes me into the 3D view. And then again, even with elevations, if I click on north, it takes me into a north elevation and so on. So all of your views are kind of a text heading in this menu, and all we have to do is double click on them and it'll take us to that particular view as we start building our model. If we go back to 3D view real quick, it has all the same. Actually, let's go into a floor plan. We need to draw something so that we have something to look at. Let's click on Architecture and then click on Wall. And all I'm going to do is point, left click as a start point and left click as an end point. And I can hit Modify or Escape and end that particular program. But basically, or that part of the step, basically what I've done is I've drawn a wall. And I'm not going to get into all the different parts here. And if we look at this in 3D, it's already drawn a 3D wall that we can now, I just wanted an object that we can kind of navigate around. So you can kind of zoom in and zoom out on that. And you can also pan around. But we have another option now that we're in 3D. If you hold in the Shift key and then hold in the right mouse button, we can orbit. So this is your orbit command, so you can sort of navigate around your 3D model. You can also orbit around a model by clicking on this view cube up at the top right. if you start to click on different parts of the cube, it'll take you to different views of the model. So it's kind of a fun little thing you can play around with, but you can click on different parts, top corners, midpoint corners, even elevation views, and so on. Other ways to zoom in, you've got this little icon off to the right. There's this little zoom with a down arrow. You have zoom in, zoom out, zoom to fit, and all these other options there as well that you can sort of navigate around and play around in. Now, I'm not going to go over all these tools right now, but what you might want to do at the end of class or after class is you might just want to open this back up and kind of look at what all the different tools are that are available as you click through and get real familiar with what's in each of these tool ribbons, because we'll be referring to these throughout the semester, and I'll tell you to click on something and go to another part. You might have different tools than I do, especially when you get into add-ins. I have a lot of add-ins here. You're probably only going to have a few in there, so there will be some things that will look different on my screen as we work. If you click on the big R up the top left, it'll bring this drop-down menu, and that's basically your applications menu where you can open up new files, do a save, print. So what we're going to do right now is hit close and close out of this file. I'm going to go ahead and let's go ahead and save this. I'm going to say, it says, do you want to save changes to project 1? I'm going to click yes for now, and I'm just going to save it. One thing I want to point out, look down at the bottom, your file for a project environment file is going to be saved as a .rvt extension. So you see that in parentheses up there. Anytime you see that in your Windows directory or on your USB stick or wherever you're looking at, if it's .rvt, that's a Revit project file. And of course, when we start downloading things for this class, that's something that you can only open in the project template or that project environment that we were just in. So I'll just hit save for now. I'll override it. And we're getting close to the end of class, but what I want to do is open up a look at the family environment. And let's go to where it says new conceptual mass under families. And the way I got to this was I just hit close, and it took us back to this splash screen so that we can start to open up other files. So if you go to families and click on new conceptual mass, and before let's click on this template here called mass, and we'll just click open. This will take us into the family environment. And then what I want to do is just do a save as real quick. So I'm going to go back up to this applications menu, and let's do a save as family. And all I'm going to do here is I want to zoom in. All your family files have a different extension. They're called .rfa files. So anytime you see that, that means you can only open it using the family environment. So that's something we have to get used to seeing, is that you're going to have two file types as you work through Revit. So anything you open or save in the family environment is going to be this .rfa, and then anything in the project environment is going to be a .rvt file. I don't really need to save that because there's nothing there, so I'll close out of that or cancel. Now you're going to notice in this family environment that there are different tools available. So when I hit create, there's insert, there's view, there's manage. There's different tools that are available with each family that we start to utilize. And I'm not going to get into all the parts of the family environment yet, but essentially there's a template for every type of family that you want to draw within. So right now this is the conceptual mass, which means we're going to be doing massing within here. There's a separate template for if you want to draw a door or model a door. And when you click that particular template, you're going to have a whole other set of tools that are available for there. So each family template that you get into, and you can kind of get into that by, let's close out of this real quick. If I were to click on new families, if I just click on new, these are all the different templates that you can open. And just as an example, I'm going to click door, click open, and you're going to see here that there's going to be a different way that this looks, and I have different tools that are associated with this environment. So depending on what family you're in, you're going to have different tools that are available to you. I'm going to close that, and then we're going to open up one last thing, and then I'll talk about what the assignment is and what to do for Thursday. Let's go back to the new conceptual mass. I'm going to open up this mass template and click open. So one thing that you're going to have to get used to in Revit is there's going to be a lot of opening and closing of different files and different dialog boxes that we're going to be always opening and closing as we work. So we just have to get used to how to navigate through that. Everyone should have, if you click on add-ins, does everyone have a Dynamo button on your computer? Good. It took like half a semester last semester to get this even installed on the old Macs that were in here. Luckily, we've got new computers in here. These are all new Windows-based computers, and they all have 16 gigs of RAM. They're kind of souped up, so a lot of the stuff that we're doing in Revit, you're really going to be able to fly using these computers, which is pretty good. But one thing is, we are all going to be on the same version of Dynamo. There should be you'll see to the left, there's a Dynamo. It says 0.6.3, and then there's a 0.7.0. The 7.0 is a experimental part of, well, it's all experimental. The 6.3 is more stable. The 7.0 is where they're still trying to do a lot of, they've got a lot more things in there, and they've actually changed a lot of stuff within that part. So everything that we do is always going to be in Dynamo 0.63 as we move through the semester. But if you click on the button that says Dynamo, it should pop open another window. Mine's taking a little bit longer here. That looks like this. And essentially, this is kind of like in Grasshopper. The only difference here is instead of having all those icons that Grasshopper has, actually has toolbars, Dynamo has a menu off to the left. So if I click on Core, I see these, it expands into other tools. And I can find these different things so that when I click on, let me just do a core input. I'll just click on the first thing, angle. You can see it puts out a little plug here that you're probably familiar with seeing in Grasshopper. It can't look exactly like Grasshopper. They have to make it look a little different. But essentially, you got the whole wire diagram thing that you're probably used to plugging into something else. And we'll get into how all this operates in a little while. But I just want to get you used to navigating to these different windows because that's what we're going to be getting into in the next class. And I can just close this now. One thing is when you open up Dynamo, if you go to Help and About, you want to make sure that when you're working in here that we're in the 0.6.3 version and not the 7.0. So we'll just we'll talk about that more when we start getting into working in Dynamo. So this takes us to the end of class. You can see that obviously this is the first day. It's all about introductions and trying to get you familiar with what we're doing, what we're going to be doing. There's not a whole lot of time, not only in this class, but throughout the whole entire semester because it's an elective class. There's only 3 hours a week, and it's really not even officially an hour and a half class. It's more like an hour and 15 minutes, so we even get shorted out even more of the time just the way that it's scheduled. But essentially, we have to get a lot done within class. So one thing I want to stress is that you're here right away before 6:30. Have the computer open so that right when 6:30 hits, I can hit play and we can just roll into class and keep moving. Because if we waste 10 minutes getting everyone booted up, then that's just 10 minutes less of class that we're going to get into. So please make sure you're here on time. I have a homework assignment for you. And there will always be a homework assignment, and it's going to be based on what we do in class. Obviously, we haven't really done anything in class yet. But if you go to our class website and you click on Classes, there should be this section here called File Upload Center. And if you click on that, it's going to ask you for a username and password. Well, that username and password is in the syllabus under... let's see, where is it? Class website section. At the very end of this sentence here, it talks about there's only one section of the class website that requires a login, and your username is guest. It's all lowercase, and the password is JRow number 2. JRow 2. That's me. Essentially, that's your password. And the only reason I have that locked down is so that not everybody in the world is, uploading things to my class website. And once you get logged on, so if I hit OK here, you'll see this screen here where you should be able to see your name under here where it says select your name. Hopefully you're in here somewhere. If you're not, that means you're not on my official class register. So you want to make sure that if you don't see your name in this drop-down list, please email me and let me know, and we can try to figure out what's going on. Also, if you're not in it, or your name is on this list and you're not in the class, then I also have to get that updated in some time or fashion as well. But all you're going to do is, and for now I'll just do guest, you're going to type in your email next. Now this is very important because when you hit upload, what this is going to do is going to send you an email receipt basically saying that your file has been correctly uploaded, and it'll give you some information. And that also gives me a way to contact you just in case when you uploaded your file it wasn't quite what I was asking for. I can hit reply and I can say, hey, by the way, you sent me the wrong file, or whatever the deal is. So you're going to want to put in a valid email. And then there's this little CAPTCHA image. You're probably familiar with seeing that. You got to enter that in. It just keeps it so that I don't have spammers somehow scripting stuff to upload to my website. The next part is under specify assignment or subject. It's real simple. If the assignment was for class number 1, you're going to upload to class number 1. So for Thursday, I'm giving out this assignment. It's for class number 1. I'm giving it out here right now. I want to upload it to class number 1. So this is class number 1 assignment. And then you can either give me a message or you could just upload your file and then hit upload. One thing I just want to mention is that as we go through the semester, you might have to upload multiple files. I can only script that one file gets uploaded at a time. If you want to save time, I put a little note down there at the very bottom that says just zip your file together and upload the zip file, and that'll make it a lot easier. Now your homework assignment is this. Using this class upload site, I want you to upload to your name, use your email address, and I would like you to enter an email address that you check frequently. So for instance, like I say, I don't check my UNCC email very often. I check my other work email more often. If you have a Gmail account that you'd rather me contact you at, put that in there as your email. Because occasionally throughout the semester, I'm going to send out notifications to you through email, and I want to make sure that everyone's up to date. Or if someone answered or asked a question and I think it's applicable to everybody, I might send out an email to everybody saying, hey, by the way, here's something that you might want to know. So make sure you put in what you want me to frequently contact. Under message, I'd like you to answer 3 questions. And just a note, on the class website, I also put the assignment, and I write all this information down, so you don't necessarily have to write down everything I'm saying, but if you want to get a jump start on it, you might want to as I speak during class. But essentially, there's 3 questions I want you to answer. One is I want you to tell me why you're taking this class. Obviously, I could probably answer that for you, but everyone has a certain reason why they signed up for building information modeling. Why do you want to take this? What was your idea, or what you think you're going to get out of this class? Or you hope to get out of this class. Kind of put that in your answer. Just tell me why you're doing it. It could be something simple. It could be something long and drawn out. I don't care. I just want to know what your interest is and why you wanted to actually take this class. Number 2, I want you to tell me what software you're familiar with. So obviously it could be Rhino, SketchUp, AutoCAD, something that you've used. Also, if you use Excel, it could be something as simple as that. And you might think that's kind of weird. I want to know why, if you know how to use Excel. A lot of the things that we do in Revit with programming is actually based on Excel. So there's some things that, if you're familiar with using Microsoft Word and Excel, just put that in there as well. And then number 3, I would like you to tell me what your software proficiency is in those different components. So if you've used Revit before, let me know. Or do you think you're an advanced user, a very beginner, or intermediate? If you use AutoCAD and you think you're a whiz at it, put that down. Let me know that what you know about computers, basically, so that I can get an understanding of what the competency level is, for all the class as a whole. The last component, those were three of the questions I want you to answer. The last thing here is I want you to browse to a file, and I'd like you to upload just a mugshot of you. So kind of like what you would have on Facebook or LinkedIn, kind of something that would show me who you are, because one thing is me not being here on a day-to-day basis, I'm not going to know all your names right away, and so I like to, from the very beginning, at least put a picture and a face with a name, so hopefully I can start calling you by name instead of just saying, hey, you. In the next couple classes, I'd like to kind of learn your names. It'd be nice if you give me kind of a current picture. Some people in the past have given me something like what you looked like 3 years ago, and you had blue hair at the time, and I have no idea who you are still. So give me something at least a little up-to-date that you can send to me that I can know who you are. And that's it. And hit upload file, and we'll meet again on Thursday. And as you can see, we've gone a little bit over class time. That might happen from time to time, but it's what we can do to try to work through this class. Any questions? I can stay after for questions, or if anyone needs any help, let me know. Just with sign up or so on. We'll meet on Thursday. Thank you.